Hi, I'm Dawei. I'm from Microsoft, and this is Neha from Google. For the outline of this talk, we are briefly talking about an API-driven approach for managing the switch in our productions, which is come from gNOI. So some of the motivation is like what some of the pain point in our operations. We're going to survey where SONiC is in this API-driven approach in the ecosystem. We are going to talk about gNOI, what gNOI is, how does it work, and some example of the things that we can do with gNOI. And eventually we'll we'll go to the roadmap of how we intend to grow gNOI, or eventually we want to talk people into writing structural code with proper input, proper format, proper contract, instead of like writing a script that is supposed to run but that is supposed to live for a month or a week, but instead we're living for years. Yeah. So the motivation comes from many of the pain points of the CLI-based approach in our operations. So many of us come from it depends on what company you are, come from the operation and networking engineering or SRE experience. So as one of those, we love charging issue, we love running commands, we love running script, and eventually this carry out onto like automation is that we want to write some automation that automatically do our triaging, diagnosis, even some daily operation like upgrading a SONiC device. This is a very typical script about of how that procedure come into being. So this is not real script, but this is a very typical pattern that we can see. It's very hard to read them, first of all. And also, you might run some commands. You might run it on a physical device. It works fine. You want to automate it. You write it into the script, and suddenly 2 months later, maybe one of your CLI get a new version. Some maintenance want to change the log format and things like that, and your script suddenly break. And this is not just from script breaking, and then the problem is twofold in that if you as the maintainer of the underlying infrastructure or CLI, you say, will my change break someone else's script? And this is also a terrible position to be in. So this is all well until it is not. And then when it breaks, tickets come in and customer complains, and you want to say, okay, let's just try to not get this kind of failure into production. So we want to write unit tests. We want to write integration tests. We want to do tremendous testing. And then you come with this kind of script, and then you think about yourself, like, how do I even unit test this? This is a script that full of hidden dependency, full of side effect. It is not really sure that after I run the commands, the result, is it observable? Like, have I really deleted the file? Have I really changed the configuration in the way that it's supposed to function? Is the change accepted by the system, and things like that. So eventually it leads down to that you have to write very brittle tests that says, okay, as long as I run this command, I consider it pass, but had it done the thing that it's supposed to do? I don't really know. So the overall thing is like, it's very hard to establish confidence when we incrementally change our workflows and does daily maintenance. So this either leads to someone who are really experienced have to review the code somewhere, or have to always review the code, so it is not scalable, or the development suite getting really, really slow. There are also other issues. Like one of the typical issues that I typically run into is like, suppose we are doing an upgrade and some issue comes in, we go to the vendor and the vendor will ask, what exactly was the step that you do for the upgrade? then maybe we'll share a 2009 script, and by the time that the vendor get the script might already change. So this all comes down to the fact that scripts are for humans, and they encrypt many of the very tribal knowledge that are subject to change, and that might not be there like even in 2 months and things like that. And also one of the costs that we often overlook is the resource cost. Like if you write script, like if you add type and things like that, that's another process. So once you have a big fleet, all these resources adds up. So if the bottom line is that by automation with script, we automate the execution and we scale the execution, but we didn't really scale the visibility to how well it works, and we didn't even really scale the confidence that it should really work. So that's why we want an API-driven approach to write proper code in, like, for example, a formal compile language or like Python and things like that. So SONiC is a very good place to start because like we have a very strong foundation on this. Like we are an open source ecosystem. We have many adoption, which means that people are collaborating and trying to establish some sort of contract between like what this step is supposed to do, like what is repave, what is reboot, like all sorts of other reboots and things like that. So for gRPC based API, like we also have a strong foundation, like with gMMI, it supports config, and we are using it to do config. For telemetries, we have gRPC based telemetry that has rich streaming data, and it is also widely used. But operation, most of them are still living CLIs and primitive script, and it's not standardized. So then there comes what is gNOI. gNOI is one of the gNXI family that stands for gRPC Network Operation Interface. So it basically complements gMMI, which does config, and telemetry, which streams telemetry. It covers many of the things that you can typically do with a very common command in Linux, like file management, resetting the device, rebooting the device, rotating certificates, rotating logs, upgrading the software, and even having some diagnosis on the service. So, for example, like removing a file, one of the pain points is like if you have different platforms, you have different commands. So there's also software between different vendors. So, but with a gNOI, all you do is creating a client, fill up a very abstract, a somewhat abstract request, file the RPC, and then get a response. You are more clear about what's the contract promise between the server and the client, and then what does it happen if it's not, then why it isn't. Another thing that we wish to highlight was like let's figure out how healthy is the CPU right now. Many of the current systems are still relying on scrapping certain patterns from syslog. These are brittle. These are brittle. These are like very subject to change, and it made people scared of changes, and you don't know which day it might break. So, but with a structural API approach, you got a single input, you got a single output. You can use a maintainable code, testable code, and encode all these into like a standardized client APIs. So, and testable. Okay, I'm going to hand over to Neha to talk about some of that. How does the gNOI server work?
Hello, everyone. So I'll just get into the details of gNOI itself, the integration workflow, and how we've seen the operational workflow transformation. So the first thing is about gNOI integration overall, the client server system. Just going through it very quickly. we have incoming gNOI requests that the first endpoint that gets serviced by the gNOI container is already in SONiC along with various other containers. So the main primary mechanism we use for routing to the corresponding backend entry is dbus. And through the gNOI container, we have a dbus channel. Then based on whichever gNOI service that is, it gets routed to the corresponding SONiC host service that say either requests that require direct operating system or hardware access like file and so on. And once through SONiC host service, there's also another state synchronization and the messages that happen within SONiC containers that happens through Redis database. So that once, say, an OS installation or a system reboot has taken place, then things get updated in the Redis DB, and that is then used for polling status. And here, just going through a simple example using OS installation, we'll go over through CLI and then through gNOI. This just is a sample snippet of the steps or a multi-step approach that take place during OS installation. You have, say, issuing an install command that goes to a remote file server, gets appropriate image, then installs some switch. You have multiple timeouts here, the confirmations with the direct step-by-step mechanism for the installation. But this also highly device dependent, and then based on any of these errors, the timeouts, or say even the verification, because the verification also uses a lot of the string parsing and relies on that to actually generate if something was successful or if it failed. And outside of the regular process of installing, you also would have a separate external script or a loop that requires a post-reboot verification phase. That could be, say, waiting for a fixed delay, running SSH and ping to make sure the device is reachable, running show version after SSH is successful, scraping the output, and then and so on. So these all steps, there are a lot of, as Dawei mentioned, there are a lot of the cases where if CLI output changes, if the messages change, things in the pipelines that get affected. And with gNOI, we do have these, for OS installation, we have the RPCs that directly target this. We have the transfer, activate, and verify. And what these do is with transfer, this is based on the OpenConfig gNOI proto directly. It takes in the file server, gets the image from the file, from the server itself, and then starts the request. Once the transfer is completed, then that continues on with the installation itself. And everything goes here directly from the client, just has to call one RPC. And then with the server implementation, that takes care of all these steps. And then that goes to the corresponding dbus, gets the input from there, updates the image. And once that's done, then we're able to verify that using activate and verify, where we use make sure the updated software version is current on the switch. And once that's done, there's also an example added here for the gNOI client that we use, where you can also issue this in the command line, but it also follows the same step-by-step mechanism, but it also has this in the protocol format. So the response would actually send across the exact error codes that you would see, and or we'd expect or expected or unexpected both. And also once you have it installed, you can also validate using the version directly. One of the biggest things that we've seen in using gNOI is the improvements that we could see with get-with testing. Main thing is it actually enables unit testing with mocks. That handles a lot of scenarios that we've seen would be missed otherwise. Correct error handling, the streaming, all the schema compliance for OpenConfig port as well. But also just a few examples listed here with multiple failure success scenarios for each of the RPCs and services. There's also, it has enabled us to test in the virtual switch environments that reduces dependency on physical hardware, CLI scripts, as well as the multi-vendor interoperability that ensures we have seamless coordination with standard multi-vendor gNOI clients and tools, and that also reduces any integration risks that we've seen. And overall, just summarizing here in the workflow transformation. So going by atomicity, that with traditional scripting, we encountered requires multiple complex steps in the scripts, which include string parsing, that especially when you want to install, reboot, wait for a particular process. And that is prone to failure if, say, CL output changes. Whereas in gNOI, you have a single structured RPC that is also stateful. The server handles all the sequence. The client receives the structured status update, status polling that as well for repeated SH CLI logins. You have string strafing for that. That can be difficult to manage with timeouts and varying device responses. For in gNOI, example being the install RPC or even the system reboot, where you have specific streaming responses for real-time structured machine readable updates. Example with the status reboot status as well. The client can ping how or doesn't can use the same RPC to generate the request itself. Similar for error handling and verification, it's hard to distinguish its expected disconnections from unexpected failures. But with gRPC structured error codes, that is something that makes it very easy, programmatically easy to differentiate between the different stages of failures. Same with verification. With scripting, you have to manually log back in, get the show version output, compare against the target, and so on. Versus here, you can also leverage gNOI to request the image version and then confirm the updated version. So the current status is we have submitted a lot of gNOI RPCs that are already deployed, that are ready to use. Some of them include the system PC that includes reboot status, cancel reboot, for OSS, activate, verify, and install, file, remove, and start, factory reset, container Z, and image management. The future capabilities that we do plan adding is the automated multi-stage OS upgrade that uses gNOI for zero-touch software distribution and deployment, along with HELZ, which is for log collection. And we're also planning to add file server additional capabilities for that and debug as well. And the call to action is, so we've seen a lot of benefits having gNOI in our automation platform. So we'd encourage everyone to integrate the gNOI, use API-driven approach into your platforms. There are a lot of HLDs already on GitHub, so welcome any use case contribution, any contributions to a GitHub repository. Also, if you want to get involved, there's a UML working group where we regularly discuss anything on gNOI and gNOI. Thank you.